What other questions? Yeah.
You guys, you mentioned the Berkeley students who got full cows. Have you guys played around with robots and trying to?
A little bit. Later at the party, you'll see a couple demos we'll have running with manipulation and the robot plugging itself into a regular wall outlet. So we've been playing a little bit. Our focus has been on making an awesome platform. So usually we invite people to come here and say, okay, here's your platform, use it, and then we learn a lot about how to improve it.
So one thing here that's just unique about the robot, you guys are used to looking at things and listening to things. This one you can really only tell when you're touching it. But the robot itself, the arms are very what's called back drivable in the technical sense. Basically that means if you push on them, they move, and they have they'll respond to environmental force as well. So you can see the arm is here, you can push it, you can move it to different positions. This is one of the mechanical things that makes the robot very different from a traditional industrial robot, and it makes it much more suitable for doing tasks in a human environment.
How many degrees of freedom have the haptics enabled on the arm?
So all of the degrees of freedom have the high quality motor current feedback that makes that possible. The degrees of freedom in the arms are the most back drivable. The head is very back drivable. The gripper opening and closing is probably the least back drivable, but all of them can control the force.
So there was a question over here. Yeah.
So, moving forward, how often are the groups going to get together to share information? Or?
We have plans for a bi-monthly conference call where everyone will come together and share their progress. We expect people to be collaborating much more outside of that, and many groups will be doing their software development in publicly available repositories, which means basically as soon as you write a line of code, somebody else can see it and build on it.
That's what you meant. Is there a milestone 5?
Not yet.
The beta program. Sorry, one point that was left out of the beta program structure, or maybe an emphasis, is that part of their application was they're going to outline what they're going to contribute to the open source community, basically in exchange for having the robot. And they're basically setting the way we set up this arrangement is they actually have to make good on those commitments. Otherwise, of the other 78 fantastic applications to the program, we'll find somebody else to make better use of the robot.
Quick question on the controller. This is just a regular PS3 Bluetooth controller. The robot's behavior is really all defined in software. So this is basically a very simple application, which is demo yourself using a joystick. You could write all sorts of other code.
Can you have the PR2 grip something or get taller or do something like that? There you go. Something crucial.
Give him some nice B-roll.
One of the demos that you'll have access to at about 8:15 this evening after our presentation is a demo where you can basically put anything in front of the robot on a table and it'll figure out how to pick it up.
There you go. So there's a robot holding something.
It makes power screwdrivers obsolete.
Yeah, it's got continuous rotation on the wrists and also has continuous rotations on the forearms, which basically means you can turn around as long as you want it to, which turns out to be very nice for a lot of applications.
So what other questions?
This is as tall as it gets. I can show you the robot getting.
It's designed to get tall enough to reach on countertops and things and short enough to reach the floor.
Was it analyzing the thing it was holding in its hand? Is that why its camera is pointed at its hand?
No, the camera is pointed at the hand right now just because that's one of the modes. We have done that, but it's not running in the joystick demo. And this right now, it's measuring the position of the arm and using that to drive the target for the head. So as you move the hand, it knows where it's going.
Can you talk about the model for the open source food tree, the licensing, obligations that you referred to? What's really going on here?
Yeah, so the core of ROS itself, the sort of basic infrastructure, is released under the BSD license. BSD license allows both commercial and non-commercial use. It's sort of a very company-friendly license because we want to see lots of people building on top of that.
And when do you fork and when do you not fork? And how does that work?
The general model is we have what we call federated development. Okay. So we actually have have a couple different repositories for different categories of code, but all of the sort of 24 different sites right now, institutions that have their own repositories of code. Anyone that wants can create a ROS package and put whatever license they want on them. you could create a package for ROS that is closed source, and people can decide whether to use it or not, but we're not going to put anything closed source into the core of the system. And everything that we've been developing for the PR2s is open source.
Larry,
Yes,
I would raise my hand if you could.
I understand.
Version 2.
Are being used in all the robots other than the PR2? What kinds of robots will be able to use this training system?
So fortunately, we don't have to rely on my imagination. ROS is being used right now on a wide range of robots. It's being used on autonomous cars at UT Austin and Summit Stanford. It's being used on robots that fly. So like they're called quad rotors. They're sort of small helicopter-like robots. It's being used on the PR2 and other robots similar to the PR2. There's a Japanese robot called the HRP, which is similar to this, and there's something called the Carobot in Europe that are both sort of similar size, arms and mobility, and it's used on a lot of very small robots. It's used on one called the iSobot, which is called the world's smallest humanoid. People have been using it with the Aldebaran Now, which is a robot about this big that walks with legs. And it's been used all the way down to the iRobot Create and servo-based arms. So people are really using it all over the place. People are using it for very large systems, and people are using it for, it's also used on the tech side. There you go.
Oh, hello, robot.
Can you give just a quick kind of highlights tour of the main components of it?
Yeah, sure. So I'm going to run through the sensors, and then let's run through the mechanism. On the sensors, up on the head, these are cameras. These are two pairs of stereo cameras. One is wide angle and color for understanding the room. One is sort of focused and black and white, and is paired with what we call a texture projector. So the texture projector basically puts light into the world, so the stereo camera gets more accurate.
So a stereo camera works very similar to the way your eyes work. It takes two pictures of the room and then tries to find common points and triangulate. And the texture projector literally puts dots on things, so that things like a shirt without any texture the robot can see, you can still get a nice 3D information, which is very useful for robotic software and a robot like this.
This here is a tilting laser scanner. So it can tilt up and down however you want. Inside there's a spinning mirror, and this is bouncing a laser off of points in the room and measuring the time of flight to know how far away they are. This is very good for building 3D models. We use this, for example, for navigation. Right? There's a navigation stack that lets ROS drive around without hitting things. People also use the navigation stack on a variety of the other robots. This is sort of the key sensor for that. So you come down into so the sensor is inside. You can't see the inertial measurement unit. When I shake the robot like that, it's sensing it. There's sensors for positions of all the joints. There's another laser sensor that's down here. Inside the base, there's two computers. Each of them is an 8-core server that has 24 gigs of RAM. So together, that's 48 gigabytes of memory on the system. It's designed to be very good for software development. There's a battery system, which is basically 16 laptop batteries, plus all the circuit breakers and control stuff. I don't know if you want to talk through the hardware as part of the mechanism.
Sure. I don't know, if you have any specific questions, I'm happy to answer them. Eric talked a little about the arms. The arms are obviously the things that affect the world the most, and designing them to be both robust and very capable for the task we're interested in is something we're very proud of on the system.
So the degrees of freedom, the head goes up and down, right and left. The laser scanner, you can see it tilting. The arm itself, you can see moves. It has 1, 2, 3, 4, 5, 6, and 7 degrees of freedom, which is pretty similar to what a human can do. And then the gripper itself can also open and close. The spine can go up and down, and then the base itself can go forward, backwards, can turn in place, and can also drive sideways. So that turns out to be very useful.
Yeah.
Is there an actual red laser that goes out like that?
No, there's a light in the head that shines some light into the world, but there's the laser that is invisible.
What's the battery life like?
About 2 hours.
Carnegie Mellon and MIT have done some sort of tests and theories about how people interact with robots to make robots shorter than humans, more cute,
wave their arms in funny ways. Have you done anything in the PR2 to make it more approachable, cuter, or is it all just technical?
So we find a balance. Robots like this have